Hey guys, it's Miss Marnon. So we're going to do another lesson on quantity equals percent times whole. And so for our first review question, we actually have a one-step equation. So again, this is from 6th grade. You guys did learn how to do these, but I just want to make sure that we can do them again this year, just kind of review it. So we also have to remember that this 85 and this x, what's happening between them is multiplication. So I'm a lazy mathematician. I don't normally write multiply. Sometimes I even just do a dot. But like here with this x, I don't even write anything at all. So this is 20 equals 85 times x. So like how we did yesterday, we need to get this by itself. So to undo multiplication, we have to do the opposite. So instead of times, we need to divide. So if I divide this side by 85, what's going to happen is we have 85 over 85. That's just going to be 1. So what's going to happen is this is actually going to go away because when you do 1 times x, it's just x, right? If I do 1 times 5, it's just 5. So now all that we have on this side is x. But the problem is this is an equation, so it's equal, it's balanced. We're saying these two things are the same. So when we divide by 85 on this side, we need to make sure we're doing the same thing to this side to make sure it stays the same. Otherwise, it's not balanced, it's not equal anymore. So on this side, we also have to divide by 85. So if you don't have it open already, we need to get out our Desmos calculator, and we're going to type in 20 divided by 85. And we get this really wonky number. Let's see if it turns into a nice fraction. It's 4 over 17, or you could leave it as the wonky decimal. So this is 4/17, and this is x on this side. Those two things are equal. We did the same thing to both sides, so it stays equal. If we wanted to, I did this one, so it's a weird number, because what's going to happen a lot of the time if we're solving for a percent, we're going to have to divide and get a weird decimal and then convert it to a percent. So you could write 0.235 and maybe you stop it there and round it. Just make sure that if you do stop writing decimals, that you're rounding it to the correct place. So if you're told to round it to a number, make sure you round it up or down accordingly. So I wanted to make sure we went over that one. I didn't know if you guys would be able to do that by yourself, but I think you can definitely do this preview by yourself. So the number of boys in Lincoln is 120% the number of girls at the school. Find the number of boys if there are 320 girls. So pause the video, see if you can figure this out on your own. Okay, so what you should have noticed is that here we have our percent, and here we're talking about the number, it's compared to the number of girls. Anytime we're comparing to something, we're measuring by something, this is going to be our whole. So we have our equation, quantity equals percent times whole, and I might need to give myself some more room to work here. Our quantity is what we're trying to find. We're trying to figure out how many number of boys there are at Lincoln. We have 120% times our whole of 320 girls. If we're working with the Desmos calculator, we need to convert this percent to a decimal first, which we should be getting really good at. So 120% is 1.2 times 320. So on our calculator, let's type in 1.2 times 320. 384. If you remember, you could also do this 120% of 320. In both ways, we get 384. So there are 384 boys. Let's look at our notes here. So exercise 1. The members of Club Oswego are making bracelets to sell to raise money. Gentile and Jeanette made 54 bracelets over the weekend. They need to make 300 bracelets by the end of the week. So part A says, what percent of the bracelets were they able to make over the weekend? So we need to figure out how much they made compared to how much they needed. So figure out what percent of the bracelets they were able to make over the weekend. Pause the video and try it on your own. Okay, so if you tried this, you would know that they needed 300, that is our whole, and they made 54, that is our quantity. So if we set up quantity equals percent times whole, we know this is 54. We don't know the percent. I'm going to put an X because I don't know the number. And our whole is 300. This is X times 300. This is one of those times, like in that DIN review, where we're going to need to solve a one-step equation, just like we did in 6th grade. So because this is multiplication, if I want this 300 to go away, my goal is to get X by itself and then a number on the other side. So if I want this 300 to go away, I need the opposite of times, which is dividing. So if I divide by 300, if I do it to one side, we need to do it to the other side. So this is going to make sure everything stays in balance and equal. When we do 300 divided by 300, that's just 1. 1 times X is just going to be X on this side, and 54 divided by 300 on the other. So let's type it in our calculator. 54 divided by 300, we get 0.18. Now the question says, what percent? Oh, I didn't mean to cross it. What percent? This is a decimal, so we need to convert this to a percent by moving that decimal place over twice. They made 18%. Let's look at the next one. Gentile made 32 of the 54 bracelets. Write the number of bracelets Jeanette made as a percent of those Gentile made. As a hint, you need to figure out how many Jeanette made first. So pause the video, see if you can do this one on your own. Okay, if we want to figure out how many bracelets Jeanette made, we need to do 54 minus 32. Because these are the 32 Gentile made. Here's the 54 total. So if we do 54 minus 32, we get 22. So these are ones made by Jeanette. So we want the number of bracelets Jeanette made as a percent of those Gentile made. So Gentile is actually going to be our whole, because she's what we're comparing to. And this number here is going to be our quantity, the number Jeanette made. So let's set this up. If we have quantity equals percent times whole, our quantity is how many Jeanette made. Our percent is a mystery, I'm going to put an X. And our whole is how many Gentile made, which is 32. So if you didn't get this far, but you see it now and you know how to solve this, pause the video now and solve this equation. Okay, so this is times 32, so we need to do the opposite, which is divide by 32. And if I do it to one side, I need to do it to the other. So on the other side, we're going to have 22 divided by 32. So on this side, 32 divided by 32 is just 1. 1 times X is going to leave us with X. 22 divided by 32, we need to type on a calculator. 22 divided by 32, we got 0.6875. So 4 decimal places. So this one's the percent, not the decimal. So change this to a percent by moving that decimal over 2 places. We get 68.75%. Let's move on to exercise 2. At Lincoln, there are 104 students in the band and 80 students in the choir. What percent of the numbers in the choir is the number of students in the band? So students in the band is what we are comparing to. This is going to be our whole. So our whole is 104, which means our quantity is the students in the choir. So if we have quantity equals percent times whole, we're going to have 80 equals some mystery percent times 104. So now we have the setup. If you can solve it on your own, solve it on your own. If you need help, keep watching. So now, because this is a times 104, and we want to get x by itself on one side and a number on the other side, we're going to divide by 104. And we're going to do that on both sides to keep everything equal and in balance. 104 divided by 104 is 1. 1 times x is going to leave us with just x. Now we have 80 divided by 104 on the other side. So 80 divided by 104. We get this wacky decimal. I'm going to leave it as a decimal, but I'm going to round it to 4 places. So I'm going to copy down the first 5 places to make sure we round it correctly. So 76923. So this equals 0.76923. I only want 4 decimal places. 4 is plenty. This 5th one, because it's a 3, it's below 5. We can just get rid of it. So we have 0.7692. To convert from a decimal to a percent, I just move it 2 places over. We get 76.92%. The next question. If students in band and choir make up approximately 40% of Lincoln students, how many Lincoln students are there? So now they gave us the percent, but they're saying these numbers together are just a part or a quantity. I was going to write part, but I want to write quantity. So 104 and 80 together are 184 that are in the band and choir. So if we have quantity equals percent times whole, we have 184 equals 40% times some mystery whole, and we can keep using W. If you want, you can put an X. So now we actually need to solve. But to solve this, I want this as a decimal first because my Desmos calculator can't work with it like that as a percent. So we're going to change this to be 184 equals 0.40 times W for our whole. Now, because this is multiplication and I want to get the letter by itself, the W by itself, I'm going to do the opposite of multiplying, which is dividing. And I get 0.40 on this side. If I do it to 1, we're going to divide it on the other side too. 0.40 divided by 0.40 is just going to be 1, and 1 times W is W. 184 divided by 0.40, we get 460 students. Really, we're closer to 500, but still a pretty good problem. Okay, last exercise in our notes. Is 2 hours and 30 minutes more or less than 10% of a day? Explain your answer. So this one, we can't really use quantity equals percent times whole. I mean, you can. So let's see here. I know that a whole day is 24 hours. So this is our whole. Let's figure out what 10% of a day is. So we have some unknown quantity. I want to know what 10% is. We're going to do 10% times the whole day, 24 hours. So we just need to multiply this out. 10% is just 0.10 times 24. And I don't need a calculator for this one. I just know when I'm multiplying by 0.1, it's the same as dividing by 10 or moving that decimal. This is 2.4 hours. So 2.4 hours is 10% of the day. 30 minutes is half an hour. So 2.5 hours is the same as 2.5. So 2 hours, 30 minutes is actually going to be more than 10% of a day. So we can write a mini little CER right here. So let's get my writing out. Let's make it big and purple. So 2 hours and 30 minutes is more than 10% of a day. 10% of a day is 2.4 hours, and 2 hours, 30 minutes is 2.5 hours. just in those two sentences, we have our claim, we have our evidence, and it's our work here too, and some of our reasoning. So now you have these practice problems. So this one's a little tricky. You're going to have to figure out what that amount increased by, just like how we had to figure out how many bracelets Jeanette made. So what was that actual increase? That's going to be the quantity, not the starting price or the ending price. The original price will be your whole, but you got to figure out what that quantity is for that increase. Then you have a problem similar to what we did yesterday on our DIN about ages. And then you got a problem about my sister's pet lizard. I guess he's not a lizard, he's a bearded dragon. And also Milton, I think, ended up having eggs last year. So I guess Milton is really milling, but probably still identifies as Milton. So we have our exit ticket, we have our practice. We're going to use quantity equals percent times whole. When you're done, make sure you go into Canvas and complete independent practice 20.